So good morning, students. So let us write the code for the matrix multiplication in parallel programming environment. So we have into libraries. .h, then include a string, then include time.h, where we are going to use some informations or functions, some library functions from time header file. Then our omp.h for parallel programming. We use parallel programming environment in our code. Then using namespace standard to get the meaning for CNC out standards. Right now, let us write the code. It is our main. So here I'll declare some integer I, j, m for my calculations. Then to get the time, now I will use clock functions. Use clock t. Right. So this is most important. This is the library function. Return the number of clock ticks, what you consider as used since the program has launched, right? Then C1, C2. Now I will add the for loop for I equal to 0, I less than n, right? Then use I plus plus. Let us take the n variable, then for loop, and write another for loop, the most important for getting the matrix values. So for J already we have declared equal to 0, J is less than n, J plus plus. Here we will input some what we consider as the values inside this array integer. So before that we have to declare this particular before using this array. Let us declare this here. This hash define n and float. Then we'll use the array that is n, right. So similar b and c will take. for B for matrix, C for result. So here we'll write B, here we'll write C. Right. So I have defined this. Now we will use this particular array here. We have I j equal to. We'll use some function that is a random function to input directly the values instead of taking from user. Right. So similarly for B also we'll write this. So we'll input the values in the B also. That is also random instead of taking from user. So now our A matrix and B matrix contains the values. Now we have the two matrices. Now our particular we want to find out the time and we have to run that code parallel. So now we'll define C1 underscore 1 equal to CLOCK. This function is most important. Now this function, this clock will return the value starting time of this particular execution of this code, whatever we write below this statement. So whatever it will start from 0, and when it will end the loop, we'll again take another variable which will take the whatever time currently after execution of that code, we'll take another variable. Now, so C1 will take some value, take the 0, and now for initially we'll set, it will measure the time, starting time we can consider. Now, so number of threads, how many number of threads actually this parallel programming will create. So that for that we'll write printf that is a max number of threads. So we are considering that it should use the maximum number of threads to execute our code parallelly. Maximum number of threads. Maximum number of threads. So here we write OMP underscore get underscore num underscore use threads. Right. So this function most important. So maximum number of threads. How many maximum number of threads it will be used for parallel execution. We can see then for running the code parallelly. Now our code will start hash pragma OMP parallel. So we know that to execute our code, how many number of parallel threads it will create, and that we want to show here. That we want to tell that. So pragma OMP parallel will tell that more number of threads will create to execute the code parallelly. Right. Now we will write hash pragma. So hash pragma OMP single will tell that only one thread will be used to execute this block of code, whatever we write now. So only single thread will execute this whatever code we will write here. Printf number of threads. Right, printf number of threads. Going to get number of here. After this, what we'll do is that hash pragma will be parallel for private, right? So by using this private, we can consider that so each thread having its own instance of variable, right? So by using this private, so this is also important statement. Then we will write the for loop for multiplying the matrix for I equal to 0, I less than n, I plus plus, right? Now we will write the code for this. We require again another for loop for j equal to 0, j less than 1, j plus plus. Now we'll write your code our actual matrix multiplication will be carried out in this, right, section. In this block of code we will write now C of, or capital C here, C of I j equal to A of I j into B of our matrix multiplication, normal matrix multiplication. However, normally we do I j. Now this is important, plus C of I j. I j. Right. Now your matrix multiplication will be carried out in this block of code. So after this, once the execution will be over, what we want to know is that how much time it has taken. So we will write that particular, measure the time, right? So we'll measure the time after this, right? Check out the brackets, all brackets should be closed. C1 we have to clear. Now we will write C2. Now we'll take another variable C underscore 2. C underscore 2 equal to now clock. CLOCK clock. Now this is the end time. C2 will store now end time. C1 will store the start time. C2 will store the end time. Right. Now, what we should know is that whatever we get in the C1 and C2, that is what in terms of ticks, but we want in terms of seconds. So we have to write the formula. Now we have used one variable, that is a T1, T1 underscore 1 equal to, that we have to use float. Now this is a C1 underscore 1. Now we have to use 2 because 2 is because T is the end time, C2 minus C underscore 1. Right. Now we have to write divided by clocks, number of clock ticks per second. That is, we should write CLOCK Dual or series clocks for CCA and these clocks per seconds, right? So after using these clocks per second, right? Clocks per second, we will finish it. So now we'll get the T1 will get the time and this code will run parallel. So now you know that what is the result? The result is C of ij. That only we have to use the for loop and we have to display the output, right? So like this we can consider. Now let us execute whatever code we have written. cd gw cd bin, right? Now we know the command g++ minus f 1 p, right, dash open p. Then after that we'll take the file name. What file name we have written? Matrix multi, right? multi.c output file exec, right? We have compiled the program. We don't have any error. Now we'll execute exec here. Now we have matrix A and matrix B. The number of threads, 4 threads are created. You can see that to get the number of threads in that we have output the number of threads, and the result you can see that first row, first column, first row, first column, first row, second column, first row, third column. So result we can see that. So first row 1 into 2 2, then we can see that 4 into 4 16, 4 into 2 is 8, and 3 into 2 is 6. So we can get the result that is 6 8 16 and 2, the result is 32. So we can see that 32 result, and we are getting the execution time, that is end time minus initialized time, that is 0 0. So we get that 0.022 in seconds we are getting. This is the matrix multiplication by using the parallel programming environment. Thank you.